Hello everyone. In this video we're going to solve a new problem, and that is find anagrams in a string. Okay, so what is anagram and what does the program want to show us, we will see. Okay, so you are given two strings s and p, like this one. Okay, and your task is to find all the start indices in s where the substring of an anagram of p. Okay, so an anagram means it uses exactly the same characters with the same frequencies, but the order can be different. That means, guys, if I show you here in our program, right? You see, this is our program. Okay, CBA. So this is the S string and this is the P string. So P string has three substrings ABC. So wherever you see ABC all together, okay, in a row, okay, like CBA. So these are the letters of ABC, right? So all the three letters are here. So this is a anagram of ABC. Okay, so and if you exclude C and you have BAE, so this is not a uh, anagram. Okay, because E is a different letter. Do you understand? AEB is not an anagram, EBA is not an anagram, BAB is not an anagram, ABA is not an anagram, BAC is an anagram, right? So this is the thing, guys. Okay, so what we will do, we will try to visualize, simulate the program. So here we have two strings and then return size. Okay, so in this we have integer indices, and this is a pointer. Index is a pointer to integer, and we have find anagrams. So in a word, you can remember that, guys, where you have to, in a program where you have to return an array. Okay, so there maybe there you have to write like this one, pointer indices. Okay, if you just return only one letter, or maybe only one number, then you don't have to provide asterisk here. You don't have to point, you don't have to provide like pointer. Okay, so find anagram sp and return size. So return size also, guys, a return size is this is address of return size is going to be provided here, right? And then we have to go to the main function before we move to the printf, because this is the function call, right? So you come here. What we will do, we will just copy the strings, right? Let's copy the strings, and if we see that 0 1 2 3 4 5 6 7 8 9, so we have integer n, strlen s. So length of this is 9 and length of this is 3, right? Return size equals 0 in the beginning, and if n uh, smaller than m. Okay, so if n is smaller than return null. This is because, guys, if this is not bigger than this ABC, so we can't find the anagram of 3. Okay, anagram of them. Okay, so this has to be the bigger than this one, this ABC, right? So this is why this condition is coming here. And then we have count p26 equals 0. That means, guys, we will take an array of 26 elements, and all of them will have 0, okay, as the value. So here you see we have count p0, count p1, count p2, count p3. So all of them has the value 0. We have 26, but we are showing here only 4 5 maybe. We have s as well, so we have s0, s1, s2. So this is how it goes, guys. And now we have the for loops. Okay, so count characters in p. So we will count all the characters in p. Okay, so first iteration. So we need to take the strings here. Okay, this will be comfortable for our eyes, guys. We don't have to check again and again. So I is 0, I starts from 0, and m is 3, right? Because we are counting the characters in p. So count p third bracket. Or if you see here, let's think about the inside first. Okay, so pi, that means when I is 0, pi means first element of p array, right? So a minus a is 0. So count p, the whole thing will provide 0 here. So count p 0 is, we have the value count p 0 is 0. So we have plus plus. So that means guys, we have to increase this. So we'll increase this one 1. Okay, and then count as I equals, so as count as a, that means c, right? 0 0 c minus a equals guys 2. So in the position 2, in position 2 count as, we have to provide 1. I hope you understood guys. And then we have to take 2 more iterations, right? Second iteration is 1. So pi, if it's 1, then it's b, right? B minus a is 1. In the position of 1, in the position of 1 we have to provide 1. And here you see b minus a. So in S array we have to provide first position 1. And then we have the third iteration. So we have a here, c b a, right? Count p, sorry, is c here. So c minus a is 2. So here we will have to provide, in count p we will have to provide 1. And in this s we have a, right? A minus a 0. So here we will have to provide 1. So you see values are same, 1 1 1 1 1 1, right? So count 0, count p 0 1, count p 1 1, count p 2 1, count s 1, count. So these are the same, right? So now we will have to allocate result array. So we know that how it works, guys. Okay, so result is pointing to an integer variable, and we are allocating memory for n number of integer. Okay, so what is n? N is 9, guys. Okay, so we will allocate an array of 9. Okay, 0 1 2 3 4 5 6 7 and 8. This is how it will work. Okay, so this is result array, guys. Okay, result 0, result 1, this is how it will work. Then now we will first window check. We will check in the first window, that means in the first 3 letters, that it is a, if it's a a anagram, right? So now we'll have to check this if statement is equal. So is equal is a function, guys. We defined this function in the top of the program, right? So I take this is equal here. Okay, so you see integer a, pointer b. You see here we just passing count p, count s. That means, guys, count p array and count s array is being passed here. Okay, so as they have a lot of numbers, they have a lot of elements, so we have to we have to point to each of them. Okay, so this is why count pointer a, pointer b, they are pointer because a and b is not pointing to an individual number, it's pointing to an array. Okay, so come here, sp. Okay, so first iteration I equals 0, I less than 26. Okay, so because we have 26 elements in each array. Okay, p and s. So if ai and not equal to b, return 0. So in our case we have equal, right? In our case we have equal because ai means a0, guys. So in a0 means count p0, right? b0 means count s0. This is how. So all of them has the value 1. So it's not that this condition is true because these are equal, right? So of course after maybe second iteration this will not be true, third iteration this will not be true, and finally it will return 1. You understand? When it returns 1, then this condition is becoming true, guys. Okay, this condition is becoming true, then this result return size will be in the first return size is 0, so result 0 is being placed 0, right? 0 is being placed in the result 0. That means, guys, in our 0th position we have an anagram, right? If you see here, CBA, so in 0th position CBA we have an anagram, right? So this is the thing we got here, and now the return size will be increased, so return size will be 1. You understand? In the beginning return size was 0, so now the return size will be 1. We will we will have to use this later, right? So now we slide the window, we will slide the window. So let's come here, first iteration. So now we will take this we will take them. Let's say we are just putting this in front of our eyes, so that we get easily. So I starts from M, that means 3, guys. I will start from 3 because we don't need to check the 3 first 0 1 2. We can count from the E, right? First 3 we just checked, so N is 9, right? So now count Si minus A. So what is I, guys? I is 3, so 0 1 2 3. Here we see E minus A, that means, guys, 4, right? So in count 4, count as 4, we will put 1, and then I minus M. What is I minus M, guys? I is 3, M is 3, so C will be so C minus A, right? So that means 2, guys. So this will be minus minus, so mine in 2 into 0 1 2, this is going to be minus minus, that means it was 1, so we'll have to make 0, right? So now we'll have to compare counts. So if we now compare, then count P and count S will not be equal. You understand? This is because, guys, if you see here 1 1 1 and rest of them are 0. Here you see 1 1 0 0 and then 1, then rest of the 0. So they are not equal now. You understand? So we will have to take the second iteration. Second iteration, here I would be 4, 4 is less than 9, okay? So count as I. What is I, guys? What is I for? So I is 4, right? So 0 1 2 3 4. So B will be here, B minus A, that means 1 1 plus plus. So count as 1, this would be 2 now, and then count as I minus M, okay? So 4 minus M, that means wait a second, yes, okay, 4 minus M, that means 4 minus 3, that means, guys, 1, right? So here B, there B as well, right? So here you will see minus minus again. So here it was B minus A, 1 1 minus minus, that means, guys, it will be 1 again, right? This will be compared again, this condition will be false again. Now we will see the third iteration. Third iteration, right? 1 2 3 4 5 6. Okay, I is 5 less than 9. Okay, so Si 0 1 2 3 4 5 2 3 4 5. So A would be here, A minus A plus plus, that means, guys, count as this would be 2, and I minus M. What is 5 minus 3? 2. So 0 1 2, A minus A minus minus, that means again 1. We're just trying to simulate, guys, okay? This is simulation, and compare again, they are not equal, right? So fourth iteration now, fourth iteration. Here we will have 6. 6 is less than 9. Okay, so 6, 0, 1, 2, 3, 4, 5, 6. Again b, right? So b minus a, that means 1 plus plus. So in this 1 we will have 2, and then I minus m, that means 6 minus 3. 6 minus 3, what does this mean, guys? 6 minus 3 is 3. Okay, so 0, 1, 2, 3. So here it will be e minus a, that means 4. 4 minus minus, right? So here you see 0, 1, 2, 3. 4 minus minus, that means 0. So this was fourth iteration. Let's go for the fifth iteration again. Okay, so fifth iteration we have 7 here. 0, 1, 2, 3, 4, 5, 6. Okay, okay. First iteration starts from 3, second iteration 4, third iteration 5, fourth iteration 6, fifth iteration 7. Okay, so we're just simulating, guys. This is not, anyway, I will give you the code, you will do the same. Okay, so if you want to learn, you have to do the same, right? SIB, guys. So if you go to 7, 0, 1, 2, 3, 4, 5, 6, 7. So here b minus a plus plus 0, 1, 2, 3, 4, 5, 6, 7 plus plus, that means 1 plus plus. As b minus a 1 plus plus. So guys, something is wrong. Maybe I just made something wrong, but yes, I simulated this before. It worked. Okay, so maybe this time I made some mistake somewhere, but if you try few times, this should be okay. But we have to understand the how the code works. Okay, and we have to write them when we overall write the whole program, then things feels so clear, right? Anyway, 3, 4, 0, 1, 2, 3, 4, 5, 6, 7. So a minus a, let's check again. 0, 1, 2, 3, 4, 5, 6, 7. A, right? So a minus a, 0 plus plus. So here you see 2 and 7 minus the 4. Okay, so 0, 1, 2, 3, 4. 4 minus minus. Okay, so something is I made something wrong here, but finally if you see here, okay, CBA, EB, ABA, BAC. So in this iteration, in this here, we will get another. Okay, so here we will get another matching. You understand? And then we will come in the output. So return size would be, return size would be 1. Yeah, return size would be 2, right? Because in the previous iteration it was 1. I'm going to show you. We had return size 1 here, right? So we will get another anagram, so we will have return size 2. So we will come here, return size 2. 2 would be, I'm going to show you in this. Here there will be 6 in 6th. So I would be 0 and return size would be 2, right? So printf indices I, that means I 0 will be printed, and if I is return size minus 1, okay, so a comma would be printed, then it will get the second iteration, guys. And now in this position it will print 6. You understand? And then a new line, and free indexes would be free, and then return 0. So this is how this program works, guys. So if you want, we can see the time and space complexity of the program. So let's just see the time and space complexity. But we have you I if you want, you can take the code from me and try to visualize, guys. Okay, so someday I tried 2-3 times before. So someday I can match, and sometimes I can't match, because only a simple mistake can, make the whole program broken, right? But I have to try, and I have to, write the same code again on my own, right? So give me time and space complexity. Okay, so here counting characters p for loop. This loop runs m times, sliding the windows over s. For loop, okay, I plus will this way n minus m times, comparing two frequency arrays is equal. Okay, inside is equal 26 character every time, one constant time. This happens once per window. Okay, m minus, so total time om plus o. So time complexity is on, for time complexity on, and space complexity should be o1, right? Frequency array, okay, result array. Worst case, every index of s is an anagram start up to n result. Okay, space for output, final space complexity on. And okay, guys, so I hope you understood, and if you didn't understand, then try to spend some time. I will give you the code, so try hard. Okay, thank you for watching.